Hi, everybody. Ms. Lee here. Today we're going to be talking about series and summation notation. So summation notation or sigma notation is how you write a series, which is the sum of a sequence. So we're going to go ahead and write all this down. So all this new vocabulary. So if you want to go ahead and title your paper Introduction to Series and Summation Notation. Okay, that says summation. So SUMMATION. Okay, so for vocabulary, we have series. So what is a series? Well, a series is the sum of the terms of a sequence. Sum of the terms of a sequence. So if you remember what a sequence is, a sequence of numbers is basically just a list of numbers with some sort of like pattern or rule that they follow. And so the series would be if instead of commas in between them, you put like plus signs between them because you add them all up. And so we'll also be talking about or using the word summation notation. So this is going to be referred to as sigma notation or summation notation. So if I say something like, please write this in summation notation or please write this in sigma notation, this is what I mean. And so the Greek letter sigma, capital sigma, is written as something that looks like this. So kind of like a backwards 3, kind of like a big E, whichever one you want to go with. And so we put certain values in certain places, and these each have names as well. So here, for example, we're just going to put in numbers. So here we put k equals 1, and then at the top, we're going to put 5. This is the ending value. So this is the starting value. This is the ending value. Most times k is going to start at 0 or 1. Sometimes it doesn't, but most times 0 or 1 is the starting value. And this is sort of like our counter, and you're going to count up to 5. So it's like going to go 1, 2, 3, 4, 5. And then k squared plus 1. So this is just going to be our example function. And in general, the variable that you're going to use is the variable that's right here. So I'm going to go ahead and describe what each of these are. So this is your ending value. And this is going to be the rule or expression for substituting values from the index. And the index is this right here. And so k equals 1 is our starting number or starting value, and it's going to be our counter. As I said earlier, you're going to count from 1 up to whatever the ending value is. So you do all of the integers in between. And then k, we call k the index of summation. K is the index of summation. Okay, so specifically something like this will evaluate to an actual number. And so the way we evaluate this is you basically start at k equals 1, you go up to 5, and you plug in every number into the rule or the expression that they gave you. So for example, for this one, we start with k equals 1. So 1 squared plus 1, that's 2. We'll do k equals 2. So 2 squared plus 1, that's 5. K equals 3. That's 3 squared plus 1, that's 10. K equals 4. 4 squared plus 1, that's 17. And k equals 5. 5 squared plus 1, that's 26. Okay, so to evaluate this example that we're doing here, so to evaluate this summation, what we do is we add up each of these numbers. So I'm going to go ahead and write that out here. So basically, the sum from k equals 1 to 5 of k squared plus 1 is going to be 2 plus 5 plus 10 plus 17 plus 26, which adds up to 60. Okay, so just to reiterate, you're adding up each of these numbers. We're adding up each of these numbers, and that's what this equals. So this equals the sum of each of these numbers. Okay, so that's summation notation. Go ahead and do a few practice problems, and I'll see you in a bit. Happy day.